Okay, so here they are asking us to interpret an exponential equation. Those are slightly more complicated, but there are nice patterns there as well. But let's start by reading the story, seeing what they want. The function n defined above can be used to model the number of species of brachiopods at various ocean depths d, where d is in hundreds of meters. So it's underlined for a reason, guys. Which of the following does the model predict? Okay, now these are kind of already sounding like points, right? So for every increase in depth by 1 meter, the number of brachiopod species decreases by 115. Okay, so honestly, this is a case where let's just plug points into equations. Let's arithmetize a little bit. So let's start with d equals 0, right? That's the easiest thing. D equals 0. And if we put 0 in there, remember what happens? And anytime you have something equal to the 0 power or raised to the 0 power, it becomes 1. So this whole thing would be 1. So when d is 0, we have n of 0 is 115. Okay. So that already doesn't bode well for A and C, because if 115 is kind of our starting point, is that an increase or a decrease? Probably not. But here's what we can do. We can easily choose a new number for D and kind of see how this is going to change. But let's make our lives easier, right? D is in hundreds of meters. So if I make D 1, that's really 100 meters of difference. Okay, so we got to be careful with that. But if I put 1 in, then I'm going to do 115 times 0.90 to the first. So let's just do it for the sake of having a number. So times 0.9 is 103.5. So there's a little bit of a decrease there. So now with that in mind, let's just see if the choices make more sense. For every increase in depth by 1 meter, the number of brachiopod species decreases by 115. So we increased by 100 meters and it didn't even decrease by 115. It decreased by like, what, 12? Something like that. So this doesn't even make sense. For every increase in depth by 1 meter, the number of brachiopod species decreases by 10%. Well, the 10% might be right. That seems good. But we're not increasing by 1 meter. We're increasing by 100. This is the key to this question. So this is the trap answer, where if we plug points in, it feels kind of right. But we have to recognize the units of these points. That's what they're trying to get us on. But again, they underlined it, right? You should have seen that is going to be important. It's underlined. C, for every increase in depth by 100 meters, now we're talking, the number of brachiopod species decreases by 115. It did not decrease by 115. It decreased by far less than that. And so then here, probably right, for every increase in depth by 100 meters, the number of brachiopod species decreases by 10%. And if we recognize how exponential equations are built, we should recognize that this is really the open formula with a slight adjustment, right? O is the original. That's 115. So O times 1 plus or minus p, because it's a change, right? So that's 1 minus 0.9 or 0.10, sorry. And that's where the 9 would come from. And so that's why there's a 10%, because it's not 90%, it's 10% less. And so that's the 1 plus or minus kind of doing its thing. Whereas we don't really see it as a 10%, we see it as 90%, but it's really because we lost 10%. And then the new value is just over here. And we throw a little exponent on there, t, d, whatever it is. That's the open formula, but we use the open formula when we are taking a percentage and we're doing it once. But an exponential equation is taking a percentage multiple times, right? So for every increase in depth by 100, we can go 200 meters, 300 meters, 1,000 meters, and it'll still keep doing the 10%. That exponent is capturing that repetition. We don't really need to understand that for this question, but I do think it's important to recognize when they're trying to trick you, and that underline is them saying like, hey, we're trying to trick you. So pay attention. Sometimes the SAT is pretty obvious about it. Don't mess those situations up.